डिग्री तो बनेगा उसका ना. So we'll start discussing the things related to start a discussion. And right now I'll be trying to discussing the introduction to 3D geometry. That is few questions I can try a few questions which are simple in nature from the topic of 3D geometry. Okay. So the question what I'm trying to take is this. Find the distance. Find the distance find the distance of points P 3, -5 and 6 from x, y and z axis and from x, y, y, z and zx planes. So the solution we can now think of. So when a distance of point from x, y and z axis. So the point 3, -5 and 6. So we can calculate the distance from the axis will be let us say the distance from the axis we can calculate directly, as we know the formula for this. We know that distance from x-axis of a point P, x, y, z is root of y square plus z square, and similarly can be found for other axis also. So just a moment, let me check something here. So when we write here axis, we are talking about single axis, and when we are writing axis means this, then we are talking about multiple axes. So finally I can confirm that therefore distance from x-axis is equal to p with the 3 minus 5 and 6 root of y square plus z square, that is minus 5 whole square plus 6 square, that is 25 and 36, that is root of 51. From x-axis we are having root of 61 or 51, root of 61, root of 61, the root of 61. Similarly distance from y-axis is 9 plus 36, that is root 45, and this can be further written as 385, and distance from z-axis is obviously it is 9 plus 25, that is 34. So that is the part. Axis, from the axis we have calculated now, and now we are planning to calculate from the plane, xy plane. From xy plane, let us say the xy plane is there. Distance will be from xy plane, the distance is we'll take vertical distance or not. So in this question what we have done is distance of point P from x, y and z axis we have calculated. Xy plane we are, if we are calculating, it will be a perpendicular distance, and directly we can solve it. As per my understanding, we can solve it directly, since P, point P has the coordinate 3 minus 5 6, that is x coordinate. So distance from xy plane, distance from xy plane will be z. From xy plane will be z coordinate or not? Will be z coordinate is equal to 6 modulus of 6. The modulus of z coordinate is modulus of z coordinate, that is 6 distance from yz plane is modulus of x, that is 3, and distance of we have xy, yz, xz plane, modulus of y, it is 5. These are the answers for this particular question. So we have calculated this. Okay. Let us move forward with the direction angles and direction cosines. Okay. Direction angles and direction cosines. So direction angles and directions of cosines, how to calculate that we have to understand. Okay. So direction angles and direction cosines, let us discuss now. So direction angles and direction cosines, let us understand. In the figure, let us firstly draw a figure. So here we need to have a 3D figure first, and let us write the heading first here. So direction angles and direction cosines we'll try to have. Before that, we should have the axis with us. This is x-axis, this is z, and this is y-axis. And let us now draw the, let us say from a point P is there. So this we are constructing it. Okay. So how to, this is 90 degree here. Yeah. So now I will be joining the OP. Let me join it first. OP, this is okay. This is 90. This is 90. This is 90. Now this angle, this point P, this, let's say this point is E, this C, A, F, B, D. And more line I'm just trying to make here. That is, this angles, what we are trying to make here is also 90. Angle made by OP, let us say this is O. So OP is making an angle. This point is O. Okay. So OP is making an angle with the z-axis, that is gamma. So angle made by OP, that is gamma, and this will be the angle made, that is gamma. Okay, and the same OP makes an angle, the x-axis also, that is this angle is alpha, and it makes an angle with the y-axis also, that is the above angle, that is beta. So we can make the statements like in the figure. OP make positive angles. Anti-clockwise alpha, beta and gamma with x, y and z axis respectively. These angles are known as direction angles. These angles, so these angles are in anti-clockwise direction with y-axis, that is beta, alpha and gamma. These angles are known as direction angles. These angles are known as direction angles that we have written. Taking cosine of these angles, we get cosine of these angles we get cos alpha, cos beta and cos gamma. Direction cosines make it easy to represent the direction of a line and a vector in space. So direction cosines, these are direction angles, that is correct. And cosine, if you take it as a cosine, direction cosines. Direction cosines make it easy to represent the direction of a line and vector in a space. Direction cosines make it easy to represent direction of an angle, direction of and angle, direction of a line in vector in space and vector in space. So what we should do here, so in triangle we are looking after some triangle part. In triangle ODP means this triangle ODP, so it is at right angle at D, and if you find cos of alpha, so base upon hypotenuse, that is x, because the for P we have the coordinates for P. We have X, Y and Z. So it will be X by in triangle ODP cos alpha will be equal to OD by OP, and we know that for OP distance of the point from the origin is root of all the coordinate squares. This X by root of x square plus y square plus z square equal to L. Similarly, in triangle OEP and OFP, so OEP and OFP, so these are the triangles we'll take, and then directly we can write the conclusions here. Cos beta will be equal to y upon the same part, it is x square plus z square is equal to m, and cos gamma is equal to z upon the same part, that is the square is equal to n. And further we can write here if we add both all the RHS, so L square plus M square plus N square, if you add all of them, it will be 1 only, because root will be vanished out and it will be 1. Okay, so L square plus M square plus N square is equal to 1. It's a very very important relation between direction cosines. This is the relation between direction cosines. Okay, so very important conclusive relation is there, and now we can work on this 1.6. So